The project that Amy and I were assigned for the video project is a piece of metal weighing 59.04 grams was heated to 100 degrees Celsius and then put into 100 milliliters of water. Initially, it was at 23.7 degrees Celsius. The metal and water were allowed to come to an equilibrium temperature determined to be 27.8 degrees Celsius. Assuming no heat loss to the environment, calculate the specific heat of the metal.
Step 1. Determine the specific heat of the metal measured in joules over grams times degrees Celsius. Given the information in the question, we know that the metal is 59.047 grams and was heated to 100.0 degrees Celsius. Since it reached equilibrium temperature of 27.8 degrees Celsius, the change of temperature for the metal is 72.2 degrees Celsius. We know that there is 100.0 milliliters of water, but since we need grams, we convert 100.0 milliliters to 100.0 grams. We are now setting up the formula. Since we need the specific heat capacity of water, we use 4.19 joules over grams times degrees Celsius. And to cancel out the grams, we use 100.0 grams on the numerator and 1 on the denominator. And then we use 4.1 degrees Celsius on the numerator, and then in the denominator we use 1. And then since we need to cancel out the grams, we use 1 divided by 59.047 grams, because we need grams on the bottom. And then we use 1 divided by 72.2 degrees Celsius since we need Celsius on the bottom. We need to cancel out our units for step 3 to find the specific heat capacity on the unknown metal measured in joules over grams times degrees Celsius. So now we'll cancel. After we multiply 4.19 joules times 100.0 grams times 4.1 divided by 59.047 divided by 72.2, we would get 0.403 joules divided by grams times degrees Celsius. This is a rounded number since we needed 3 significant figures. But since we know that this is an exothermic reaction because energy is released, our final answer is negative 0.403 grams divided by grams times degrees Celsius. This will be our final answer.